Alright, this is a video for 3HD about exercise 49. Now, in one of the previous videos I explained that from chapter 7 from now on you're going to use one of the three things you learned, either the sine, cosine or tangent, right, or the Pythagorean theorem, or using similar triangles. Now with exercise 49a we have to calculate the length PQ, right, so we're going to use one of those three methods, so either tan, sine or cosine, or the Pythagorean theorem, or similar triangles. So why don't you think about which one that you need to use here. You can pause the video if you want, and then when you unpause it I'll say what you need to do. So you have to use the Pythagorean theorem here, right, because we don't know any angles. We can calculate an angle first, because there are multiple ways to calculate this. You can calculate this angle, and then with that angle you can calculate the opposite side if you'd like. You can also calculate that angle using the cosine, and then use the angle in this side to calculate that side, but then you do a lot more work than you need to do. I think the Pythagorean theorem here is the easiest, because if I want to calculate PS, I have to do the square root of 6 squared minus 4 squared. Right, and then you know what PS is. And then PS is, well, rounded off, it's 4.5. And then if you want to calculate QS, then we do the square root of 5 squared minus 4 squared, which is 3. And once you have those two numbers you can calculate what PQ is, because then PQ is those two together. So PQ is 7.5. Alright, so that's exercise 49a. Then we're going to take a look at exercise 49b. Here we have to calculate DE, that's that one. Alright, so again, one of those three things you need to use, the Pythagorean theorem, or the sine, cosine or tangent, or the similar triangles. The one you have to use here is similar triangles, and there's an easy reason to see why. Because if you want to use the Pythagorean theorem, you need to have a right angle. If you want to use the tan, sine or cosine, you need to have a right angle. This one doesn't have any right angles, so the only thing that we can do is use similar triangles. And what we can see here is that triangle ABC, so triangle ABC, is similar to triangle EDC. EDC, yeah, because this angle is the same as that angle. It's actually called an F angle, because you can see a sort of backward, sideways F there, and this angle is the same as that, because also you can see a bit of an F there, right? Right, so ABC is the same as triangle EDC, and then we have to calculate the length DE. So I'm going to make a ratio table here. In this length we have AC in the big one, well, AC is 8, and then in the smaller one we have CE, which is 6, and then in the big one we have AB, which is 3.5, and in the smaller one we have DE, which we don't know. So if you want to calculate DE, then you have to use the cross products. So 6 times 3.5 divided by 8, that is the answer. So the answer is 2.625. That's the. So this was the answer for exercise 49. Thank you for watching, and I'll see you later. Bye bye.